Despite not traveling to outer space, the Middletown High School rocket team is reaching impressive heights with their model rockets, preparing to fly competitively this upcoming spring.
It's like a little club. I think there are around 13 of us, depending on who shows up, and we participate in the American Rocketry Challenge.
The American Rocketry Challenge, founded in 2002, is the world's largest student rocket competition. 5,000 students compete nationwide to design, build, and launch model rockets.
The competition is a national competition where teams are given certain tasks to achieve with a rocket, certain baseline things the rocket has to do.
The competition has a variety of different requirements. Each rocket must reach an altitude of 850 feet and remain airborne for 42 to 45 seconds, all while safely carrying an egg.
Our rocket design it has 3 different parts. There is like the base tube where we have the fins attached and where the combustion motor goes. And then we have the payload tube because it has to carry an egg and has to bring it back down safely to the ground. And then we have the nose cone, which just kind of friction fits into the payload tube.
The cone pops out, and you have a cone right here that separates the payload from the actual rocket as to protect it better, and that kind of allows the parachute to come out from the middle section.
The rockets must be created from certain materials to allow them to reach the required height.
This is a lot of the material we make it out of because it has to be light so the rocket actually goes into the air because we have a minimum altitude. So this is a kind of an early prototype we had, and yeah, so it's made out of this so it's light and goes higher.
In addition to creating a rocket that fits the criteria, members of the rocket team apply their scientific knowledge to improve their design.
The engine combusts, and that creates a large amount of energy, which propels the rocket upwards. And not to get too sciencey, but that's an oxidation reduction reaction, which is redox, which the specific fuel for rockets and the engines is very electronegative.
The motor ignites, it propels stuff out the bottom end, and that creates an equal and opposite reaction, which makes the rocket go up into the air.
Impulse, momentum, force, rocket science.
The rocket team is currently testing their rocket and adapting the design in preparation for official qualification flights.
We've done a couple flights already, got it stuck in a tree, had to climb it and get it down off the tree. We've repaired it, now we're going to fly it with some other motors on a less windy day to see if we can reach the target altitude and target flight duration.
Despite a few setbacks, the rocket team is looking forward to the challenge.
It's looking promising, and we will be able to meet our goal.
My favorite part is probably just getting to work on a team and build something that we all at least had some kind of part in. I think it's pretty cool.
Just kind of tinkering with the rockets and then eventually seeing them actually work, actually fly. But also it's just kind of taught me things about general engineering, working with others, those sorts of skills.
It's all the students. Their drive and perseverance through some hard times those first couple of years helped show me the joy of rocketeering, which is what us nerds call it. And I really love showing that, sharing that love with the students, showing them what they can do with a little bit of knowledge of rockets, some electricity, and some explosives.
Launch.